Well, thank you for joining us on this exercise 3F. We're going to be looking at this question 2C. 2C says find the modulus of each of the complex numbers in question 1, and the complex number we're looking at is z equals negative 24 plus 7i. Now the modulus is considered the distance that complex number is from the origin if it was on a two-dimensional plane. Let's call this 6, 12, 18, 24, negative 6, negative 12, negative 18, negative 24. Let's call that 6, 12. This is the imaginary component of z, and this is the real component of z. Well, let's find where this value is. It's negative 24, 7, so it is about here. And the modulus, here's the origin, and here's the complex number z. The modulus is this distance that is from the origin. And if you remember Pythagoras' theorem, and we have a right-angled triangle, if you take the real component, which is considered to be x, and the imaginary component, which is considered to be y, then the modulus of z, we use two vertical lines each side. The modulus of z is equal to the square root of x squared plus y squared. You might remember that from Pythagoras' theorem. We also say that the real component of z squared is x, and y is the imaginary component of z squared. So either of those formulas is fine. So let's substitute. The real component is negative 24. We square that. The imaginary part is 7. And we square that. Here we go. So that's 416, 165, 176. And 7 squared is 49. If we add those together, we get 625. And the square root of 625, I believe, is 25. And so we now have the modulus of our complex number is 25. This distance here is 25 units from the origin to the complex value. I hope this has helped. Until next time, stay happy.